Okay, so in this tutorial, I will explain or provide a case study of how to implement a world-level language model using long short-term memory that we explained previously in the previous videos theoretically. So first, we imported like some important libraries here and functions, and we have this text that we've just copied from this website. So the first step, like, is to use or fit a tokenizer on this text, so as to create a vocabulary that we will use for the further processing in the next steps. So let's go like step by step. So first we will have, so here as you can see, we imported the tokenizer from keras.preprocessing.txt, so we can immediately use it. So it's instantiated here, and then we just need to fit on text, I think, yep, and we will provide our text as a list. Okay, so now after fitting that, we will have the vocabulary, and to like derive that vocabulary, we just need to access the word index from the tokenizer. So word index, and we will take the length of the words, but we will add one. So this one will be like for any out of vocabulary words that we may like encounter. So let's just print the vocab, how many number of words, of unique words we have. Okay, so we have 48. Right, so the next step is to prepare the input and the output to, like for our network. So here, like in our case scenario, we will, use the approach of having like one word as input, and then the next one will be the output. In the next step, we will like append the prediction in the previous step to the input, and we will use the next word for prediction. So basically we have for example, in this case, data as input and then scientists as output. In the next step, we will have data scientists, and then we will have try as output. In the next step, we will have data scientists try and two as the output, and so on and so forth. So let's just do that. So we will have like a list, then we will loop through that, loop through this text by splitting it by the new line. And then what we will do, so now we already like fit the tokenizer on the text. So now we want to convert each of these into its corresponding unique integer. So we will have encoded, and we will use t dot texts, I think 2 sequences, yep, 2 sequences, and we will provide our line as, of course, a list. And here we will use this, like the single output from this list. So basically, the text's 2 sequences is a method that that's used to like convert a list of texts in 2 sequences of integers, where each integer represents the index of a word in the like tokenizer's like vocabulary. So here, when we use like this 0, we are accessing the first element of the returned list, which is the encoded sequence of the input text. Okay, so I hope that I just explained this like very well. I'm not sure, but leave me like a comment if you didn't get that, so as I provide some examples. All right, so we have encoded the text now, and what we will do is preparing the data. So we will loop through, for I in range, we will like loop through the data, starting from 1 to the length of the encoded text that we have. And then looping through that, we will take, the encoded sequence, and I will explain this once I just print that so as to, understand by example. And then we will take the sequences and we will append, each time we will append that sequence to that sequences. So basically what we did is, let me just, print the sequences. All right, so what we did is, as I said, for example here, data is 1. Okay, so its index in the vocabulary is 1. And we have scientists, which is 10. In the next time step, we have data scientists as input. And then we will have try as the output. In the next step, we will have these 3, right? These 3, data scientists try. And then the output will be 2, right? And so on and so forth. All right, so now what we have to do is to we know that in neural networks you have to use a fixed length input, right? So all the input that iterate through the network must be of a fixed length. So in this case we have to use something to bad these sequences to a fixed length in general. So we will use something called bad sequences, but what is the maximum length that we have to use here? Because we can see that these sequences are of varying lengths, right? So what we have to do is to find the maximum length of these sequences. And so, for example, let's say max is max of, so this is how to find the maximum length. So we will have the length of the sequence. So this is a list comprehension, right? To loop through that. So for S in sequences, and let's see what is the maximum length here. Okay. So the maximum length is 17. So we have to add that to the maximum length. So let's just add that. All right. So sequences, it's nothing but bad sequences. I will provide the sequences, right? I will provide the sequences, and I will use the maximum length of the max one. Okay, which is 17. And of course, I will set the truncating to be pre, because we prefer the last information. It's better than using the post. And then I will just convert that to NumPy array. Okay, and after that I will prepare the input and the output. Okay, so we haven't okay, so we have to just, okay, let me just add it here. I think it's better. I mean the bad sequences. So from TensorFlow, I think it's TensorFlow.keras. I'm not wrong. Let's try. Processing sequence. Let's import bad sequences. Yep. And let's import NumPy as MP. All right. Good. So now let's prepare the input and the output. So we have X and Y, which is the sequences. So we will use the first, all the rows, right? And then we will, like ignore or remove the last one. So the last one here is the output. So this is the input, but this is the output. So here it means that I will take all the rows, right? But the last element in each row. So in all the rows, but the last element in the row will be used, or in the column, let's say, will be used. So here we have all the rows and all the columns, but we don't use the last element in the sequence. Hope that it's clear. And then we use the sequences. This is the output, which is the last element. So from each sequence, we take the last element, which is my output. Okay? I think there's something wrong here. Right, and what we will do is just converting the Y element into, one hot encoding. Okay, because we will need to generate like a probability for each and every word in the vocabulary. So we just need to convert that to one hot. We will use the vocab here. So the number of classes, yep, is my vocab. Okay, and that's it for preparing the input and the output. So now let's define our neural network. So let's define the network. Create model. So here I will pass the vocab and the max one, which is the maximum length that we will use, because we said that it will be fixed. We will use sequential model because we don't have like two inputs to the model. So it is like a good practice to use that. So we have sequential. And now we will start adding the layers. So first we will start with embedding. Why? Because we are using here words, right? And for the embeddings, the first thing we will add is the vocab, and then the embedding dimension. I want that to be 10, and the input length will be basically a max 1 minus 1. So the maximum length, but it should be like minus 1. So the input sequence consists of, like max 1 minus 1, right? Where max 1 is the maximum length of the sequence. And when we said minus 1, so this is used because the last word in the sequence is the target word that we want, the model to predict, right? That's why we said max 1 minus 1. So after that, we will add our LSTM model, but I don't want to add it just LSTM. I want the bi-directional. Then we have our LSTM. So let's use 50 maybe. And it's actually a hyperparameter that you can tune. You can use any value that you want. So after that, we will have our dense layer, model.add the dense, and we will have, as many, like we will have as many neurons as there in the vocab. I mean it's 48. Yep. And the activation will be the softmax. So softmax, because we are using multi-class classification. Then we will compile our model, right, where the loss is the categorical cross entropy. We have the optimizer, which is atom, and then we use the metrics. We want to use track the accuracy at the end of each epoch, and then we will just return the model. Okay, right, and just let's create our model. So let's just use this same values. And after that, we will use the model, or fit the model on our x and y, and the epochs, let's put it as 500. So those are the number of epochs that we will use. All right, so let's have a look. Okay, so we have a problem here that we haven't defined the bidirectional, so let's just add it here. Okay. Okay, so now I will pause the video until the training is finished, and then I will get back to you. Okay, so we can see that the model is doing pretty well on the training data. So let's now do the prediction or the generation task. So let's define the function. So it's pretty similar to the one that we did in the previous video. So we have the model, we have my tokenizer, we have also the maximum length, which is the max one. We have also my text, and also we will have the number of words that we want to predict. So the first thing is to have in text equals to the text that we have, like we provided, and then we will loop through the number of, so we have in range the number of words that is given. So this is basically how many number of words you want the model to generate, okay, for after this specific text. So the first thing we have to do is, of course, any text that is given must be of the same length of the text that's generated, that's fed into this model. So we used the bad sequences, right, in order to bad that to the maximum length. And so the first step we did is to first convert the text that we have into integer, right? So encode integer them. So first let's just say encoded, and we do the same as we did with the original text. So we just need to take that tokenizer, sorry. So we take the tokenizer, and we just, because we already have the vocab, right? So texts to sequences, and we give it that in text, but it must be like in in a list, and we have to take the first single element provided by by this list, and then we just need to encode that using the bad sequences. Autocomplete, please. So we have the bad sequences, and we just need to provide that encoded. So in the last time we have a problem here, and so the maximum length is the max one that we are providing, and we just do the same way. So we have the truncating, which will be pre, as we said. So this is batting the sequence, and then we just need to convert that to an array for efficient process. So just provide the encoded, and that's it. We just need to do the prediction now. So we will have y hat, we will have our model dot predict, and we will give it that encoded sequence, and then we need to actually take the highest probability, and that's done here by using the argmax to find the highest, let's say, number of the index. So mp.arg max will provide y hat, and axis equals to, okay, so we want the highest the highest probability. So we want to take the generated the corresponding index to that specific word. So how to get that? We will have an empty string, and we will just loop through, for word and index in the tokenizer. So my tokenizer dot word index, because we know that the vocab is there, dot items. And so we will ask if the index, if the index that is there in the tokenizer equals to the index generated by generated by this operation, which is stored in y hat. If they are equal, because this operation retrieves the index of the highest probability word. Okay, so if the index equals to y hat, then we just need to take that empty string and put the word in it, right? And pray, right? And then we just need to take the in text, my original text, and add that word to it. So we will have an empty space, and then we will add that out to it, because we want to generate the text one after the other. And that's it. So we just need to return that in text. Hopefully the model can do very well here. All right, so this is my function, and let's just call this function. I probably can take this because we just need to take, okay, so the text that I want to provide, let's say, okay, so let's say I want to say data science course. So for example, I want to provide this, and I want the model to generate, so this is my text, and I want the model to generate how many number of words after this? Let's say 10. All right, so it says that expected none 16, found shape 17. All right, so we have a problem here that sequential is incompatible, expected shape none 16, but found this shape. Okay, so the problem here is that we are giving the maximum length, right, which is 17, but in the model, what we are doing here is giving maximum -1, right? So I have to pass the max -1 here, because this is the maximum length of our model, right? Okay, so this should work, and we can see here that data science, and it generates after the data science 5 words, as can be seen here. Okay, so that's it for today, and I hope that it was interesting and you've learned something out of this tutorial. Thank you for listening.